Python's graphical user interface capabilities aren't really built in Python per se. Python sits on top of what's called Tickle TK. That's the way you can say it. But this is a open source toolkit. I think it's probably written in C if I remember right. And it's typically associated with Linux, but it's not exclusively therein. And so Python created what's called TK interface, TK inter, that is Python's connection to TK. It's Python's what's it sits upon to draw all the widgets and GUIs and everything else that goes from that. So the interesting thing about that is that means that if you go look at the code for Python GUI stuff, all it does is call some other library that you don't see, and so it's like all this pass through stuff. You don't actually see much of it. Um, but in TK-Enter, there's a bunch of classes that I can take advantage of. So there's TK itself, which is the window, the place you get started with everything. And then inside of TK-Enter, you have labels and text boxes and entry fields and the frames and all sorts of stuff that go on here. A frame is like a little box you put stuff in, and a frame label is text box on that label. Canvases you draw on, and string bars are variables that are strings that you can use to dynamically change text on a screen. Then you have buttons and radio buttons and checkboxes and scales and list boxes, all the standard things you'll see. Now, I'm not going to show you every single one of them here because probably you're familiar with them from using GUIs, and you'll see them as we go through and code anyway. So I wouldn't necessarily worry about memorizing these per se, so much as getting good at looking them up as you need it. Like, hey, I want to do a slidey bar thingy. So just Google TK enter slidey bar thingy and then find it that way. And I say that not because, it's not useful to know, but because there's always something new. If you just kind of find one way to do it and keep doing it that way, you never necessarily go and figure out the next new thing that's coming out. Just kind of mostly remembering it and Googling it from time to time gives you the opportunity to, find out new and different aspects about the language, and then also reduces the need to memorize it all at once. So given those widgets, those components, we need to figure out how do we lay them out on a Python screen. So the layout is kind of like, this marching band right here. They're obviously in the shape of the United States and Illinois specifically. That's the band showing here. So the state of Illinois is the only one highlighted inside of here, a little bit oversized. But the idea of the layout manager is each one of these band members has to be in the ideal spot for the whole thing to make sense. If the tuba players are a bit off down here at the bottom, you don't have Texas showing up, and if there might be more of them up here. So each different person has to be in the correct position, which sometimes is absolute. I'm standing at the center of the 50-yard line, and sometimes it's relative. I'm 2 feet away from this person, and that notion of this layout manager is important because our graphical user interfaces typically change size. Not every screen size is the same, and users often can make their screens bigger or smaller. So if you do something like absolute sizing, it absolutely must be at this location, this pixel location, you could end up drawing something that's off the screen. So this layout manager helps us manage this idea of staying on the field, if you will, staying visible on the field. And so in Python, in the TK enter, there's 3 typical ways you will build the layout. So place is what we talked about. I'm going to absolutely place this at some XY location on my graphical user interface. And if it's too small, too big, it ends up in that position no matter what. Pack is a way where everything just kind of gets squeezed together. You have one thing, the next thing, the next thing, and they just squeeze together within the space that's inside of there. And then grid is a way of viewing it where you kind of looks at rows and columns. I'm going to put this on a like an Excel spreadsheet, if you will, rows and columns. But the grid actually allows us to span multiple rows or multiple columns, like you can also do in Excel if you are a power user. You can make things that are taller or wider than things around them. So these are the common layouts. It's not actually necessarily as powerful as what you can do in other languages. Java and C have much more powerful layout managers that you can choose from. But it's perfectly good for everything we're going to do here, and there are other customizations that you might find. But that's all we're going to deal with for now. I just want you to be aware that there's other ways of doing it in the larger programming world, but these are the ones we're covering for now. But as I said, the other big mental shift is this idea of event-driven programming. So we talked about it before, that the user gets to pick what they want to do. And what that translates into our programming model is that mostly we just let them fill out data all they want to on our displays. And when they hit the button, we respond to it. So I don't have to say, give me your first name, give me your last name, give me your age, give me your driver's license number. You type in whatever you want to in whatever order you want to, and you hit the submit button. And then I can go through in whatever order I want to, and I say get name, age, driver's license, everything else like that. Um, so there's different types of actions I can respond to then, depending on the type of interaction I want with the user. So there's keyboard actions. So I can press or release a key. I can, if you're coding a video game, I can use up, down, left, right, WSAD, whatever you want to control a video game, and you can track those actions. Or you can track the actions as somebody types. You can say, hey, you type this character, you're not allowed to, or something like that, if you wanted to do that sort of action. Those tend to be annoying to users, and they're not very common to see, but it's an option. The more common are mouse actions. So I move a mouse, I press the key, I release the key. So you can see those more often. Or the very most common is component actions, where I either click something or I focus on something. I click on a text box, for example. If you've ever had a text box where there's text inside of there when you're not clicked on it, and then you click on it and the text deletes so you can see what's supposed to go in that text box, but then you type in from there. That's a focus in or a focus out. Like when you leave a text box, you can validate that text field if that's something you want to do. Again, a little bit overbearing and can be annoying to users, but is useful in some situations. We also talk about activating or deactivating components. These are all the different things that you can respond to. So instead of thinking of programming and GUIs in terms of I start the program here and then I do this and this and this in sequential order, I just think of it as, okay, when somebody clicks this button, I do this. And when somebody clicks on this text box and gets focus, I do that. I don't have to think of it in some sort of global control. I just think of it, when somebody asks for something, I do that thing. And so in some ways it's easier, in some ways it's much more challenging. So fundamentally, I want you to understand that designing GUIs is very, very different than the types of programming we've done for the most part, in this course and in other courses maybe we've done. We really want to investigate what the users are going to do, just in general, what functionality is valuable for them. And then we're going to plan out how do we create an interface and how's that going to look. And then I want to think in terms of events as far as that behavior goes. What's the sequence of things? Sometimes we do wizards, but for the most part, people put in some text. I validate it. I show them some errors, and they keep playing with that until they fix it. And then maybe they see a different screen based off of where they started. So it's a very different programming model, but a very useful one. It actually makes our lives much easier because we don't have to, think ahead and know everything the user might do. We just simply create functionalities. And so, as I said, at this point, we're going to dive into coding these things. I don't want to just spend a bunch of time, showing you pictures of GUIs. I want you to see how to create them, see how they behave, get your hands and your eyes trained up to do the things we need to do to really understand GUI creation and to build them for ourselves.